Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So, response video to a Folse Nuclear guy. So he, for the last couple of years anyway, he's a nuclear engineer and he responds to kind of just the populist science videos and sometimes does some critiquing, but mostly just plays along and relates everything, even videos on, potatoes, to some kind of metaphor or analogy to nuclear power plant maintenance kind of stuff. Anyway, seems a nice enough person and all that. But having watched a couple of his videos now, yes, it just, there's no science here. Sorry. And, but anyway, there's just nothing, no critical thinking, let's put it that way. So he did a response to the Veritasium video, and it was the only coherent one I've seen so far. A couple other just assholes who just play Veritasium videos because they know they get some interest, so they just play them and listen to music or something. I mean, it's really pointless. They don't know anything about the physics, and so they're just playing a Veritasium video to get views by playing a Veritasium video. It doesn't make much sense. Anyway, I wouldn't put this in that category, but he was disappointingly uncritical of this babble, okay, about how energy works, essentially, photons and other forms of radiation. So this guy's a radiation kind of expert, and yeah, I'm just a little disappointed. So I'll play this part where he does the two slit, where Veritasium is just spouting a narrative that just is the typical fake, phony, fraud description of the double slit experiment, especially with electrons. It's just a fake. And it's just lies, frankly. And, the fact that nobody outs it as what it is, lies. This isn't the experiment. This isn't how it's done. This isn't the result it produces. It's just bullshit. And the fact that none of them will call bullshit is disappointing. And then we'll do the end experiment that was the real loop-de-doo nonsense. So anyway, somehow you can make very improbable things happen by just getting rid of the probabilities that are canceling them. So if you get rid of the canceling thing, the booger man, then all good things will happen. Some kind of, fairy tale, frankly. Fairy tales. That's all this shit is fairy tales. And you'd think the reasonable would somewhere protest, but no. Yeah. So I did email him requesting that he pay some attention to the real physics, but I didn't hear anything back, and he's made a couple of videos since, so I don't know. We'll see if he will engage in an actual conversation about actual science, not show science. But we'll see. So anyway, with that premise, leave us play the video. So this is the this is the typical. This is almost as bad as Feynman's drawing. It's not as bad, but it's almost as bad, in the sense that this pretend of waves go through the two slits and then two waves pop out, and yeah, oh yeah, okay, and it doesn't. So these are the two possible outcomes. So again, the very idea that none of these people understand that the two slits are less than a millimeter apart, and the light travels in a straight line from the 1 millimeter. It doesn't spread. The only light that's spreading, the only light that's fringe light, is the fringes. The light that doesn't get fringed just goes straight. And so all the light going in this way, okay, that's not going this way or going this way from the two slits, has to just be a millimeter apart. You can't make, there'll be a clump over here and a clump over here, because that would require the two light sources to expand like this. They don't have a reason to do that. The two slits don't have a reason to do this. So they'd only be a millimeter apart. And none of them can even figure that out. So anyway, it's just so bad. I illustrated in the previous video. I've gone over this so many times. So anyway, I just want this for the one statement that is popped in here, and I'm just like, he doesn't challenge it.
Electrons are fired one at a time through two slits.
So we know it doesn't happen. They don't do this. They don't fire electrons through two slits. I mean, the slits would have to be so infinitesimally small, blah, 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 blah. You can't do this. They shoot it into a crystal and have the bouncing off the crystal. There's no two slits involved. It's just a lie. There's no two slits for the electrons
To be detected at a screen. Now, because you can't say for certain which slit the particle went through, quantum mechanics tells us it must go through both at the same time.
Sure. So he says, sure. It's a nuclear scientist, and he thinks electrons can go through two slits at the same exact moment. They superimpose into two separate electrons to go through the slits and then turn back into one electron again somehow. I mean, come on. He's seen radiation. He's seen the little things flying off, in the cloud chamber. What are you talking about? Come on. You got to be kidding me.
Get the probability of finding a particle somewhere on the screen, you simply add up the amplitude of the...
So this doesn't... I'm just saying, if this was light as the real example, because obviously the experiment really can only be done with photons, you'd end up with a double maxima. You have two sources. If they have the slits open, you're going to get both two patterns superimposed on each other. It's not going to look anything like what this silly diagram is, so this is all just bullshit.
Wave going through one slit with the amplitude of the wave going through the other slit, and square it.
So if you look at their math, right, the math isn't from the center of these openings. So again, it's just more deception. They're drawing two lines as if there's two lines. No, there's not two lines from the center of the opening. Now, in the case of infinitesimally small slits, that is slits smaller than the wavelength of the light, yes, then you've turned a four-source experiment into a two-source experiment by making two. If you make the two slits, right, you got a two-slit experiment. You make the two slits infinitesimally small, they can't produce a wavelength of difference anymore. So you've made a single slit that's essentially a non-slit. So you've created two single slits with no opening, essentially, and then there's still some photons getting through, and so you can create a two-slit experiment out of the double slit. You can create a single slit experiment out of the double slit experiment. You can do that, but why would you? Why would you close the slits so almost no photons can get through? Why would you do that? Oh, that's right, to turn a double slit pattern into a single slit pattern. That's why you do it. And it still won't be this pattern because you'll end up with a double maxima here. So it's still a fraud.
But that's when a student raised his hand. What if you add a third slit? Well, you just add up the amplitudes of...
Alright, so we won't bother. He just, plays the video, frankly. He doesn't have anything to say to any of this mush. And so we'll go to the more important part. But it's just amazing, this whole superficial description of the reality. It's not accurate. Again, what else can you call it? It's so far from being accurate, it's called lying. All right, when you say you put it through two slits and you never put it through two slits, it's just fucking lying. So it's not the electron experiment. You got to understand, electrons are charged. You can't send them through any kind of surface towards any kind of surface without expecting them to react to the surface. So it's just so silly. All right, so let's get to this.
Switch to Verizon for just $25 a line and get iPhone 16 Pro. Get 4.
Alright, so let's play some of this.
Look at all those arrows and see where they line up. And so if I turn on this light, that's exactly where you see it reflect. So that the angle of incidence is equal to the angle of reflection.
Mm-hmm. Right, so it's a spotlight. So the light, he's pointing to a spot, so indicating that the light actually does create a spot. And then a bunch of light around the spot. Okay, so that has to be sort of understood when he's doing this experiment. Anyway, so play a little further.
But now what I'm going to do is I'm going to cover up that spot so that we no longer see the light reflect.
So we do see the light reflect. So that's the part that's just kind of right there. You should say, well, what do you mean? I can still see the spot. I see the spot even better because all of the diffused light is now dulled because that got more absorbed. And now I can just see how bright the spot actually was because now it's still reflecting off of an opaque dark surface. There's so many photons that the opaquency can't absorb them.
And then I'm going to prove that Feynman is right, that really light also goes like this. It's just that...
So it's more, he's going to prove something extraordinary with a crackerjack box experiment, essentially. And this, like I said, this guy's a nuclear power plant technician of some kind. He doesn't say he's a physicist, so he's something related. And an engineer, nuclear engineer, I guess you could say. And this is all viable from his perspective, that the magical non-probable photons that are 1 billion to 1 likelihood that a photon goes in that direction and does this wacky thing, he's going to collect enough of those to see them. Come on, too ridiculous.
Most of the time,
I mean, even if you believed in the 1 billion to 1 photon, why would you believe he could collect enough of them to make them visible?
those effects are canceled out. Now, that sounds impossible, right?
It sounds silly and stupid and frankly girly physics. It's just, it's trivial and childish and juvenile and ridiculous.
But let's zoom into this tiny piece right here. Then we see all these different...
So all of this is happening in tiny little sections of an object, and it's this assumption that somehow photons hit surfaces in these small quanta, and they don't, in the sense that a photon has to be received by a collection, a blob. It can't be received by an electron. A single electron can't absorb a photon. It has to be absorbed by a substance, a bunch of atoms. That's the only way we could possibly detect electricity, for example, from the receiving of a photon, is you need matter to do that. You need a lot of it. All right. Photons have a gigantic polarization. Thousands of, 500 atoms at least. 500 atoms of polarization. So how can something that's going across 500 atoms be hitting one electron? That in itself is a ridiculous statement.
Paths, and all the arrows
Some
just
good
go
resolution.
around and around
Some good resolution, he says. So that's his comment.
in circles. So when you add them up, they all just cancel out. But what if I cover up about half of them like so? Well, now when I add up those arrows, you suddenly do see a large resulting arrow. And so if I can sum...
So he's not covering them up. So anyway, he's not going to make some opaque stripes. He's going to use a diffraction gradient, which is layers where there's two thin layers and then no layer, then thin layer, and so or else it's cut grooves. So it's still transparent. You can, you can see through it. It's not a bunch of blocked light. It's still lots of translucency. So it's still transmitting photons very well from one surface to the other surface. Let's put it that way. It's not blocking half the light. You can clearly just look at it and see that it's not blocking half the light.
somehow cover up this mirror in many, many tiny strips,
Going back to the slit
then I
experiment.
should be able to...
So he called it a multiple slit experiment, where, technically that's exactly what it is. And what happens when you do a multiple slit experiment? So let's just draw that real quick. I think would be appropriate. All right, so as I pointed out before, he's using a very thick piece of glass above the mirror. So, it's a very, very thick. It's always something. Irritating technical glitch. So anyway, wherever I was. So the glass is very thick, and then there's a mirrored surface. So basically when you put something on top of the surface, like a piece of fillium, what's going to happen is light's going to go through. So if it's at any angle at all, and it's got lots of opportunity to have a broad angle coming out. So that's the trick of the thick glass, is that you create lots of opportunity for separating the light from, by distance. All right, and so what happens when you have multiple slits, right? So you have multiple slits. What happens if you get 3 or 4 or 5, 6, 10 slits? What you start having is just balls of light, because what you're doing is compounding a circumstance where everything lines up. So for each slit where the, when you have a wavelength of difference, will be at a different spot. So at each spot will be a little bit different size. So you could say like the first nodes are this size, and then the second node would be a little bit bigger, and the third node would be a little bit bigger, as you get further and further distances. All right, so the size of the nodes is changing, and then you have the same pattern. So the same size one here, the same size one here, and the same size one here, and the same size one here. And there are certain locations, just a couple of locations, where they all are piled up on top of each other. So they're all going to match. And so there won't be any, they all won't match here, right? They're like half of them will match, 2 or 5 or 6 of them will be on top of each other, but most of them won't line up like a pyramid, all right, where they're all in phase. And so that'll happen at further and further distant locations, the more slits you have, and you'll just end up with all the light concentrated in those locations, because all the surfaces are making a contribution to that location. And then another location, all the surfaces are making a contribution to that location. And another location, all of the surfaces are making a contribution to that location. All right, so that's why you end up with dots separated. So and then the fact that he has, so you'll see the row of dots, and then you'll see there's another row, another row, and another row, which means that he probably has to be using a diffraction gradient, that has lines in both directions. All right, but see, we don't get any of those details. But I'm just saying that's the form of diffraction gradient you need to create the geometric spread in both directions. You're just basically doing the double slit in 2 directions, horizontally and vertically. So you say it's in a double slit, it's the triple slit or the quadruple slit or the fivuple slit or the, so you're just taking lots of lines, and you're just doing that slit experiment this way and this way. So you're going to get the same geometric pattern going both ways. All right, and that's what you end up seeing. So that's no surprise at all. And the very fact that it's going through the mirror, so it's doing it twice. It goes through the mirror, creates spots, and then the spots go through the mirror, back through the diffraction gradient. All right. Yeah, because he doesn't put a piece of paper under the diffraction gradient, obviously. So, bullshit is the point. It's bullshit. All right, so what do I want to do here? Let's just see if I can do this and if it works. Yay! Okay. So, continue playing.
Get the light to reflect like this. And I can do that with this piece of foil right here.
So there's different pieces. So he has a big piece here. You can see it's foot across, and and then later he's going to use a smaller piece. And you're just saying, why isn't this consistent? Isn't this the same experiment? Isn't he doing the same tools? And it's like, no, he's not. It's bullshit.
Piece of foil, there are about 1,000 lines per millimeter, and that should be enough to get this effect.
So I can't tell by just looking at it whether it's crossed both ways. Like somebody who knows better might know what the you can obviously see a color changes, then maybe the 2 films would look differently. I'm not sure. But my argument is that film has lines in both directions.
So let me turn off the lights. So let's see.
So whatever. He turns off the lights, but he doesn't turn off the lights consistently for every experiment.
I'm gonna turn it on in 3, 2, 1. We see it! We see it! Ah! That is so cool. It actually looks a lot weirder than I was expecting it to.
So there's no analysis of it. There's no, obviously they don't show in the actual video. They show you this little tiny inset, so you don't even get to see it full size to appreciate exactly what it's doing. But the point is that those points of light are perfectly consistent with the expectation of a multi-slit experiment.
I was expecting more like one spot, but there's many, many spots where it's reflecting. Ooh, okay.
So when he has the light, it should be pointed out at an angle. So you can see the fact that the light is shining on the surface at an angle. So he doesn't have the light overhead. So even though it looks like it's shining down, he has it at an angle. So it's shining on an angle to maximize this effect.
Okay, and just to show I haven't been cheating you, right?
All right, so this is just so patronizing and dishonest, frankly.
Right underneath is my finger.
How does this show anything? It doesn't show anything.
And even with the light on, you know, we see the light reflect. And if we remove the cover, then what do we see? Yeah, we see exactly the normal reflection where it's always supposed to go, which is right there.
So again, it's this light is enough of a spotlight to create a spot that shines back into the camera. Is there any other explanation? I don't know how else you can interpret this. So it obviously must create a concentration of the light in a spot for you to say the camera can see. Like the whole mirror isn't illuminated. There's one spot that's somehow brighter. I mean, the camera's looking at the whole mirror and he's creating a spot. So it's obviously a spotlight.
And then we've got now all these extra reflections, all these extra bits where the pattern just lines up. So very, very cool.
Very silly, unexplained, no details, just bullshit.
I was talking about this with a friend actually. He said, yeah, but you're using a diffraction grating. That's kind of like cheating because you get all these other reflections, right? And this light.
Duh. So there's obviously the laser beam itself, you know, in the dark, you can probably see it in a lot of cases. So the beam itself is hitting dust particles and creating reflections.
It's just going all directions. And so there's one other thing I've been super curious to try. I also want to do this with a laser, where I shine the laser right next to it, and then if light does take every part.
So he's talking over the guy when he's talking, which doesn't really help any. You really want to do this back, so I'll see if I can find what he said. It's just.
And so there's one other thing I've been super curious to try. I also want to do this with a laser, where I shine the laser right next to it, and then if light does take every.
Yeah, I can't tell. So he says, of course,
possible path. We should also see it come off here.
Why? I mean, it doesn't take all possible paths equally. So again, it's supposed to be an improbable outcome, not a probable outcome. So how could we collect all of these photons, you know, that are supposed to be so unlikely and improbable?
It probably shouldn't work. Actually, I have a laser right over here, and we can see when I shine it.
So for whatever reason, he's shining it from the same location. Now that should be a little bit of a giveaway. Like, well, why are you doing that? You know, you don't really need to do that, do you? You could just shine it straight down, couldn't you? And it's supposed to go over to the mirror and bounce back up to the camera. So why not just shoot it straight down at the cardboard? Why not?
It really does just go to one spot, and you can see where that's.
One small point, I think he said. So this is kind of funny. This guy's been doing these videos for a couple of years, and he hasn't figured out that you really can't talk over the guy in the video. It doesn't make much sense.
Have a laser right over here, and we can see when I shine it, it really does just go to one spot, and you can see where that spot is. It's right over there, which is about the same.
One small point. Okay, so that's what he said. One small point. And obviously when he turns off, so we're seeing the laser dot on a black surface, even with the lights on. So I'm just saying, obviously, yeah, bright lights. It's a bright laser.
Same place where we had our reflection. And you can also see...
And you still have a reflection. So let's just understand, there's just no point in saying, well, where we had a reflection, you still have a reflection.
Right now, if we look at this view, that you cannot see the laser light at all, right? Like I could see the laser, but I have to bring it down all the way.
So he's saying you can't see anything in the mirror. Yeah, because you're not shooting the lights down with a light into the mirror. So yes, obviously you can't see the light there. Oh, amazing. All right, but the fact is he doesn't do the experiment in the dark. So we can't be sure of what you could see because he didn't turn the lights off.
Way over here.
Yeah.
And then I'm able to sort of see the
So he said, yep. Yep, what?
light. But if I just put it up here, you can see the reflection. Now, what I'm going to do next is I'm going to put this foil.
So now it's a different...
Known for pursuing your passions. No one wants to be known.
I just love some cancer talk in the middle of my physics video. Shit.
If I just put it up here, you can see the reflection. Now, what I'm going to do next is I'm going to put this foil.
All right, so different piece of foil, right? So why is it a different piece? Fair question, right?
This magic foil.
So magic foil now is a much smaller piece. What, you cut a piece or what? Why is it a smaller piece? I say, what? What's the gimmick? And then he makes sure that he doesn't put it this way. He turns it this way. So watch, he's turning it right now.
And I'm going to put it over here.
Oh, yeah, I'm going to put it over here.
And we can turn off this.
This way.
And now let's see what happens when I turn on the laser.
Oh, this is so childish. I jizzed myself watching physics. I mean, it's just so goddamn. Ugh, I hate this planet.
Wait. No way. No way. It works.
Yep.
It works. So he says, yep. So he really thinks that photons go that way and bounce off the mirror that way. They do that. No, they don't.
It works. Wait, what? Look where the laser is going.
So again, you can't tell from this frame because this isn't the same picture as this. I don't think. All right. But they're certainly not moving at the same rate. So the little spot isn't moving the same way the big spot is. So that would be an indication that something's up, right? In the sense that somehow the light isn't transferring the same amount of motion, right? So if the photons are going this way, the movement of your laser is still going to screw it up, right? Those photons are going to be screwed up too. So it really has to do, I think, obviously with the lights creating a bright enough spot that in the dark there's enough photons that are going back up into the reflector of the light he's not using anymore. And that's why he was using his laser in the same location as the original light source, is to basically guarantee that it's going to go up and straight back down, because that's exactly what he was demonstrating before. It's the same angle as the original spot.
Oh my
It
god!
actually looks better with a laser because it's just more concentrated.
It looks better with a laser because it's more concentrated. So again, how's the laser producing another beam of light in that direction? So you're shining the laser this way, and somehow it's creating a beam of light over there. I mean, it's ridiculous. Okay, he's smiling. Oh, shit.
It actually works! What?
So you can see, so this is the more full-size image of the dot in here. So you can see it's a little dot. Now, if you really look at the video, you can see that the second dot is another one's being created over here because of the diffraction gradient, obviously. So it's creating another dot.
What?
So, I mean, it really sucks that all this is so edited and you really can't see the real, images.
This is definitely the coolest demo I've ever done.
Nice.
So what I was doing is,
Right. So he says something smiley, happy. Yo, yes, it's really cool. It's garbage. I mean, this is junk science, okay? This isn't how you do experiments. So all I had to do was just put a card over the light and see if he could stop the little red light from showing. Put something over the opening to the light, the reflector of the light. Obviously a very good reflector to create a spotlight in the first place, you can understand. So the spot is just shooting back into the reflector of the light that's turned off, bouncing 2 or 3 times and shooting back down.
I was holding the laser, and I can show you.
See its exact location. So why? Why do you need to hold the location, the laser there? Why can't you put the laser over here? Why should it matter where the laser is? If the light's going everywhere, it shouldn't matter where the laser is, right? Can everybody understand? Come on, you can understand this, right? Their theory is the light tests the entire environment. It even tested Saturn. Okay. And there's this idea that it's probably figures out that I'm not going to go to Saturn. Somehow it figures that out. So it's an improbable photon. Well, I don't even know you can't even describe this. It's so idiotic. But the idea is it's tested the whole theater with radar. And now you're tricking it because the stuff that was telling it had to be improbable you've gotten rid of with some little stripy film. So now you've gotten rid of the canceling thing, whatever the fuck that was. And now you have highly probable photons somehow. Okay, so instead of going this way, the photon, and hitting a surface in this direction, somehow the radar told it should go this other way. So another test they could do would see if the beam hitting the opaque surface is duller, because now some of the photons went somewhere else. Right? That's technically what they did, right? They went somewhere else because now we're seeing them in some other location. So they decided it was better to go that improbable place. I mean, this whole thing is so fucking stupid. 8 million people have seen this garbage video and nobody can say this is junk. Oh, fuck.
Right now, I was shining it down like this, way off, and you could still see it reflect. But if I take this away...
So we know an opaque, it's not the right word, what do you call scratch glass? Glass that's been, has a whole bunch of abrasions to it. There's a word for that. I can't think of it. But anyway, you use that to actually see, you can, especially for double slit patterns, other things, you can actually have light project into it and you can see patterns so much clearer. So it's a diffusion. Okay. So it's diffused glass. And obviously it creates the opportunity for reflections now that you can see. So yes, the film is diffuse enough. I mean, see, if you look through it, you can't see perfectly through it, but you can certainly see reflections off of it. All right. So clearly it's more likely you're going to see it. If you put a piece of paper there, you would see it. So that would be the key. The key way to debunk this experiment would be, instead of the film, just put a piece of paper there, a piece of white paper, and see if you have a dot. Because if you have a dot, then it has nothing to do with the film, that you're just seeing the reflection of your bright spot. But they didn't do any of that. So this is just so unscientific. I mean, it's a bold, silly claim. You really gotta do better experiments than this shit. This is carnival theater. This is a shyster, this is shenanigans, this is bullshit science. And sadly, nuclear engineers are all okay with it. Yeah, A-OK bullshit. Thank you for bullshitting me and the audience. We're all thoroughly bullshitted.
Just the amplitude goes way down.
And if I
The amplitude goes way down, so he really believes that the silly notion that a light source, you can't confine the photons, so you can't force them to all go in one direction, that they actually still send their radar beams out through the side of the laser beam, right? So the containment of the light, the photons are still going through the side or something. How are they even getting? He's pointing a laser. Okay, it's a laser beam. Does anyone think that the photons are actually going this way? There's some kind of energy going this way, testing the surface, saying, that's unlikely, let's not do it. But because it's striped now, okay, it's got a stripe pattern, now they're saying, yes, we can make photons this way. I mean, it's just so ridiculous. How can people fall for this shit?
put this back, it appears.
So that shows really that we cannot get rid of the area which...
So, of course, it doesn't show anything. So this is, look, Feynman's little gimmick was a decent enough gimmick for figuring out the further the distance. What it really related, right? Like Feynman's video, what he's really talking about is the fact that the distance you go and then reflect, your light will be in phase, out of phase, in phase, out of phase, in phase, out of phase. And so that's because it had to do with surfaces and the fact that if you polish glass, you can change how much light reflects off the top surface. And so the question is how does the glass know, okay, how does the bottom surface know what its contribution was supposed to be? And the fact is, though, is that it's made out of atoms, and the atoms are all stacked on top of each other. So the fact is the atoms know how many atoms there are. So it's like right here you could have 30 atoms thick, and right next to it it's 29 atoms thick, and then it's 30, and then it's 29, and then it's 30, because they all have to fit with each other. So the surfaces do communicate. So anyway, but that's all the clock thing has to do with is as you change the density of the material, the time it takes for the light to travel, it's going to reflect in a phase and out of phase. So the different colors will all have a different place where you can see them and where you can't see them. It's not uncomplicated physics, but I mean it has this idea that somehow you can have, when you know that it's angle of incidence, angle of reflection, all that crap happens, and that's the truth. And then they're pretending that I could shoot light this way into a mirror and have it go back this way. It's just too ridiculous. All right, so anyway.
Give zero, that it really is canceling out, and if we do clever things to it, we can demonstrate the reality of the reflections from this part of the mirror.
That's awesome.
So this isn't an experiment I've seen anyone ever do. Okay, so I've never seen anything even close to doing it, like somehow changing the probability of the bizarre photons. And, and again, there's just no evidence that's what took place here at all. All right, so it's just terrible junk science. If a flat earther did an experiment of this poor quality, they'd all be screaming fake, fraud, phony, okay? But because it's Veritasium, it's okay. Junk science is just fine as long as our guys are doing it. And as long as it's to defend our wacky, silly frickin' nonsense theory about these wooicles doing all their wooicle superpower things. It's just junk fucking science. Tragic, really. All right, so anyway, you didn't hear him much. So again, I'm just saying, this was real. There was a lot of junk in Veritasium's video, and he didn't point out any of it. So that was disappointing. And such, and so forth and whatnot. And we'll see. I mean, like I said, you can't get any of these people to discuss physics. So, to actually challenge arguments, and they just won't do it. They won't be challenged. Sucks. Okay, so enough of a video. So, till the next time and such. So I am disappointed. I mean, Veritasium, you know, Steve Mold's video got 1 million views. The Veritasium video's already got 7 million. And nobody's made a response video saying, you didn't prove shit. You know, this is not a proof video. This is not, I mean, no one even just, this isn't good science. It's crap, it's trash, it's garbage, it's just silly science. It's a bad pantomime of science. You'd almost say this is Monty Python making fun of science. It's so frickin' satirically almost bad. Alright, so anyway, till the next time, such and so forth and whatnot. Just yeah, I really feel for Mr. Smith. I hate being among you. I just hate it. I hate your matrix. Fuck it. Oh, God, you're just such balls as suck. What a waste of brains. You know, that you people can't do anything with any integrity, with any honesty. You're all just such duplicitous hypocrites. Ugh. Yuck.